So, fellow astronomers, today we're going to be talking about Nicholas Copernicus, the 15th and 16th century mathematician and astronomer who is kind of like the father of modern day astronomy. He was one of the first guys to come up with the idea that the sun was the center of the solar system, which is directly above us right now. At the time, almost everybody else, even in astronomy, thought that Earth was the center of the solar system. Pretty crazy idea for the time. Now, what we want to talk about Copernicus specifically, though, is how he came to understand that the orbital periods of the planets could be expressed in days. Essentially, he knew that Earth, as well as these other planets, were just objects orbiting the sun, so he devised a way to calculate how long it took these planets to go around the sun. And so today we're going to focus specifically on Venus. And we can see Venus and Earth lined up over here on the right. Now, this specifically, with these planets lined up as they are, is called an inferior conjunction. It's where Venus is essentially in between Earth and the sun. Kind of like an eclipse, except Venus is much, much further away than the moon, so it doesn't have the same exact effect. Anyways, in this sense, Earth and Venus are in their first inferior conjunction. And Copernicus realized that, hey, I know that there will be another inferior conjunction sometime in the near future. If I use that information, I can probably figure out the orbital period for Venus. So, what Copernicus did is first establish that, yes, Earth and Venus are both planets rotating around the sun. And second, that they are lined up in a row like this. So he kind of marked where they would be in the solar system and then simply started counting time. As soon as the planets take off, we can look at Venus and see that it is moving much, much quicker than Earth is. And that is, of course, because Venus has a smaller orbit than Earth does because it's closer to the sun. And by the time that Earth is just beginning to pass by its first full orbit, Venus is already circling in for its second. And it's this period between Earth's first and second orbit where the two planets will line up again over here on the left, just like so. Bam. Second inferior conjunction. So, once again, we have Earth, Venus, Sun lined up in a row. Cool. Inferior conjunction. Of course, we got to compare it to our first inferior conjunction over here where we started. Earth, Venus, Sun in a row. Awesome. Now, here's where the brilliance of Copernicus really begins to start, because understanding their orbits as they are, he realized that the angle between these two inferior conjunctions directly above our head was the same for both planets. This means that their time between conjunctions can be expressed mathematically in the same fractional way. I know, that's a lot of math terms thrown at you. So let's just start looking at the numbers. I'm sure it'll make more sense once we get started with that. So, first number, how long between conjunctions? 584 Earth days. Copernicus did this simply by counting the days between these conjunctions. No big deal, right? However, we want to express this as a fractional term. That way we can work it out with Venus. So, what is 584 in a fractional value of Earth years? 584 over 365. Now, the reason we're working with 365 here and not 365.249 is because, well, Copernicus back then didn't understand that the orbits weren't perfect circles. But we gotta cut the guy some slack. He's working from scratch with all of this information 500 years ago. So if it was good enough for Copernicus, it'll be good enough for us today. So for the time being, our time between inferior conjunctions is 584 over 3/65, which can also be expressed as 1 219th over 3/65, which is equivalent to 1.6 orbits. Cool. Now here's where the genius for Copernicus comes in, because Venus can also be expressed in 365ths. Its orbit, since it's the same angle position between conjunction and conjunction, can also be expressed in the same fractional value. So Venus went around the sun one more time than Earth did, so it's essentially equivalent to 2.6 orbits. Awesome. Now, since these fractional values are the same, they're both 365 at the bottom, we can set them as equivalent to each other. So, to work the math out, Copernicus set 219 over 3/65 into just one big fraction. That way it would be easier to work with. Trust me, you'll see in a second why this works out. 949 3/65 Venus orbit in 584 days just means that that period of 949 over 3/65 happened in 584 Earth days. And as a mathematical equation, it looks like this. 949 over 365 of Venus's orbits is in 584 days. Now, to work this all out, we need to look at it and how to make it properly equal 1 on the left side. Therefore, to calculate the time for one Venus orbit, we have, here's the real meat and potatoes of the equation. Try not to be scared at this math right here. Let's just start all the way over here on the left side. This is what we ultimately want to turn our weird 949 over 3/65 fraction into. One Venus sidereal period, where the sidereal period is essentially like almost the same exact as a year. It is the time between where the planet goes completely around the sun and returns to the spot to where it was before in reference to the background stars. So just kind of think of sidereal period as the orbital period for this sense. They're a little different, but just bear with me. Anyways, to get that one Venus sidereal period, we have to somehow turn 949 into 365. Now, for those of you with a little bit of math history, you know that if you divide any number, regardless of how big, weird, or small it may be, by itself, you end up with 1. And Copernicus knew this too, so he took this weird fraction and divided it by itself. But when you divide by a fraction, you end up multiplying by a fraction for reasons we're not going to get into. So essentially, you multiply by the upside down version of the fraction, and you can see right away, if we just look at the numbers, that they're the same on the top and the bottom. So we don't even have to do the math. We can just see that they're going to be equivalent to each other and thus equal to 1. That's how we get the one Venus sidereal period. Now, when working in algebra, whatever you do to the left side of an equation, you have to do to the right side of an equation. So that means we have to multiply 584 days by that same exact weird fraction. Now, using ink and paper and probably an abacus, Copernicus was able to figure out that that was equivalent to 225 days. This means that one Venus sidereal period is equivalent to 225 days. Mind blown, right? No, maybe not for you, because you're like, I can just go like Google this and get like 10 million results, or just go onto Wikipedia and figure this out. But Copernicus didn't have any of those resources. There weren't even any books or scrolls or written information about this like anywhere on Earth, because he was the first guy to figure this out. So not only did he have to come to the realization that the sun was the center of our solar system, he also had to devise this entire experiment figure out the math, and then solve it to get that answer. And now some of you haters might be thinking, well, it doesn't have a perfectly circular orbit, so it's not going to be exactly accurate. Well, look here, Mr. Mumbles. If we look at the actual value that we have today, we'll see that Copernicus was super accurate with his numbers. In fact, the actual sidereal Venus period that we know of today with our advanced mathematics and research is like 224.97 days. So, 500 years ago, with nothing more than his naked eye observations of the sky, an abacus, and an understanding of basic geometry and math, Copernicus was able to solve this problem and give us the first definitive information on how long it takes these planets to go around the sun. Whew. I hope that was as exciting for you as it was for me. Thank you so much for watching up to this point. If you like the new 360 type format, let me know in the comments. If you think it could be changed or improved some way, let me know as well. I kind of like trying this out. So any information you guys have, feel free to inform me. Until the next time though, keep your eyes on the stars.